All right, so I've been thinking about topics that we haven't spent too much time on in class, and but are going to be on the exam this week. And I came to the conclusion that I want to give you a little bit more a exposure to uh, while loops and data types. Okay, so we're going to try to combine those two things into one sketch and one video here. All right, so let's do it. Okay, so here we go. Let's write a sketch. There must be a setup function. And a loop function. And let's define a variable of type byte called myNumber. And we'll initialize it with a value of 0. Okay, and so in the setup, all I'm going to do is turn on set up a serial link between my Arduino, which is plugged in via USB, and my computer. And then down here in the loop, I'm just going to type, I'm going to actually do a loop within a loop. I'm going to do a while loop. And this while loop will be while my num is less than 100, print line my num. Okay, I want to print what my number is, and then I'm going to add 1 to it, my num plus plus. All right, and I will do a delay of 100 milliseconds so it doesn't go so fast. All right, so this is compiling and uploading, and I've got an error here. It's not print line, it's serial print line. All right, let's upload this. And now we'll take a look at the serial monitor and see what's going on. There you go. So every time through the loop, my num is incrementing by 1, and that's but it's being printed to the screen first. And then when it gets to 100, we're done. All right. If after the while loop, I said, let's reset my num back to 0 again, the way it was initially defined, then when the loop starts over again, you'll just start the while loop again. There we go, there we go. And when it gets 99, it starts over again. See? Okay, because then it goes through the while loop, and then it finishes, and it comes back to the beginning of the loop function and just repeats what it just did. And since my num is reset to 0, it goes through the while loop again. All right. So let me show you what happens if, and so this is a data type situation. Let's say we want to do this while loop as long as my num is less than 300. And then every time through the while loop, we'll say we increment my number by 3, or 3 instead of 1. Okay, so it increases by 3 every time. And then we print it to the screen, and let's see what happens here. All right, so we see my num is being incremented by 3, and when it gets to 300, we should exit the while loop. Uh-oh. Something weird happens when we get to 255. There it goes. We go back to the beginning. All right, so what's happening here is called an overflow. So if you remember, let me close this window. If we go back here to the top, my number is a byte. And bytes on the Arduino Uno are capable of storing up to 1 8 bits of data, and in decimal, 1 byte is a number between 0 and 255. And so this number, this variable, can't hold a number that's not between 0 and 255. If you try to assign a number to it that's outside of that range, weird stuff happens. Okay, so that's what's happening here. When we try to assign a number to my num that's bigger than 255, it overflows and goes back to the beginning. So we're stuck in this while loop forever. We're just going to stay in this while loop forever because my num never gets to 300. It's impossible. All right, so we need another data type. All right, so if we change it to from a byte to an int, now we should get to 300 because ints can store bigger numbers. Here we go. And then at 300, then we go back and start again because now we've exited the while loop. My num has gotten bigger than 300. All right, so let's take a look at a page in the documentation. And let's go back one level here. And if we look at variables, here's the page for byte. A byte stores an 8-bit unsigned number from 0 to 255. So unsigned means it can't be a negative number. It can only be positive numbers from 0 to 255. All right, let's take a look at an int. And when we look at the documentation here, one thing we see is that this data type is platform specific. So we're using the Arduino Uno, which is based on a microcontroller called the Atmega 328P. And on the Arduino Uno, an int can store a 16-bit number, or 2 bytes. And so that would be enough space for a decimal number equal to 2 to the 16th power. All right, but integers can be negative as well. So what we have is an integer, a variable of type int can store a number from negative 32,768 to positive 32,767. So that's a minimum value of minus 2 to the 15th power and a maximum value of 2 to the 15th power minus 1. The reason you have to subtract 1 here is there's got to be a space in memory for 0, so that takes away 1 from the positive numbers that can be represented with a data type, a variable of type int. All right, let's take a look at some other data types. Characters, char, car, care. All right, what is this? Well, it says this data type takes up 1 byte of memory and it stores a character value. Now, I posted activity 3 on GitHub, and I encourage you to play around with it. What this is that there's a standard set of characters, and these characters can be seen in a chart called the ASCII chart. Let me click on it here. All right. So, for example, the character that is capital A corresponds to a decimal value of 65. So if you create a variable of data type char, char, and you give it a value of 65, it represents the character equal to A. I think I can demonstrate that here quickly. So if let me just get rid of all the stuff in the loop here. All right, and let's do character equal to my char, and let's set it equal to the character A, and then we'll do print line my character and see what it prints out to the, I gotta save, upload. Oh, I made that same mistake again. It's not print line, it's serial dot print line. All right, save, upload, and then just take a look at the serial monitor, and boom, there we go. So it prints out the character, which is specified as A. All right, now watch what happens if I say my char equals 65 instead. And we get, boom, A. All right, so what's happening here is the Arduino sketch and the serial monitor are converting the decimal representation of the character A, capital A, which is represented by the decimal number 65, into its corresponding character on the ASCII table. All right. All right. Let's look at a couple other things here. So float. What the heck is a float? Well, float is a data type that allows you to store floating point numbers, which are numbers that have decimal points. And here we can see that on the Arduino Uno, these numbers can be as large as 3.4 times 10 to the 38th and as low as negative 3.4 times 10 to the 38th. All right, so they're stored as 32 bits, 4 bytes of information. All right, and have 6 to 7 decimal digits of precision. Okay, let's look at one more thing here. Long, short, there's a lot of data types here. So I want to show you what this modifier unsigned does. So if you have unsigned before a variable declared as type int, what does it do? Well, what it does is it frees up that byte, it frees up that bit that is reserved for the positive or the negative sign. And so instead of being able to store numbers like you could in a normal int from minus 32,000 to positive 32,000, if you use the unsigned modifier in front of int, then you can store a number from 0 to 65,535. So let's see that in action. All right. So let's do a int, a variable of type int, and we'll initialize it with a value of 0. And then we'll do while my num is less than 65,000. Let's print it, and then let's increment it by 100 every time through. Okay, and then delay by 100 milliseconds. All right. Oh, I have weird variable names here. Okay. So we'll see this value increasing by 100 every time through the while loop. And what we should see here is that it never gets to 65,000. When it gets to about 32,000, 33,000, it's going to overflow. It's going to come back to 0 because it's a variable of type int, and it can only hold numbers up to 32,000, about 32,000. Here we go, getting close, the anticipation. There we go, we overflowed. Now it's weird, right? Because when it overflowed, do you see what happened? It went from its maximum positive value to its minimum value. So an int can go from about negative 32,000 to positive 32,000. So once the number grew above 32,000, the overflow took it back to negative 32,000. So it's like a loop. It looped back around and started when it exceeded its maximum value, its maximum allowed value. It went to its maximum, or its minimum allowed value. Okay, and it'll overflow again. So it's never going to get to 65,000. All right, so let's close this out. But now let's define this not as an int, but as an unsigned int. Okay, so now this variable, my num, can't store negative numbers anymore. It can only store positive numbers. But let's change this so it increases by 300 every time. It can store numbers up to and above 65,000. All right, so it's going to be able to increment and be able to grow above the 32,000. See, there you go. So it can hold numbers larger than 32,000 because we've taken that bit that was reserved for a negative sign and reallocated it to something else. Well, let's see what happens when, so let's make this limit bigger than 65,000. So my num can only grow to 65,000. Let's see what happens when it overflows. Now, I should have made that something more than 300 so it goes quicker. But, so every time through the while loop, my num is increasing by 300 and it's being printed to the serial monitor here. So here we see that since it's an unsigned int, it can, this variable can hold numbers bigger than 32,000 up to 65,000. But we're going to get to there, it overflowed. When it got to around 65,000, the numbers we were trying to store in my num, the variable my num, were too big. So the variable overflowed, and here it went back to its minimum value, minimal allowed value, which is 0 because it's an unsigned int. It can't be negative. There it did it again, overflowed. Okay, so I'm just trying to demonstrate here a little bit of why data types matter when you're doing Arduino programming. Because, or I should say this more carefully, what matters is how large are the numbers that you're trying to store in a variable, and do those numbers have to have decimal places? If they do, then you need to have a data type of type float. If they don't need decimal places, then you can use an int, you can use a byte. If they need to be larger values, you can use an unsigned int if you can give up the possibility that the value is negative. All right, one more thing. Long. All right, so a long allows you to extend the size of variables beyond what's allowed with an int. So a variable of type long can store integer values between -2 billion and +2 billion. All right, it's a 32-bit number. 4 bytes of information can be stored. So that's 2 to the 32nd power of information that can be stored. And if you need to store numbers larger than 2 billion, you can use an unsigned long. And an unsigned long gives up the ability to represent negative signs, but allows you to represent numbers from 0 all the way to 2 to the 32nd power -1, which is over 4 billion. Okay, so if you need really big numbers in your sketch, use a long. If you need numbers on the order of 10, 20, 30,000, use an int. If you need smaller numbers on the order of 10, 100, 200, use a byte. Okay. All right, so that's a little bit of background on different data types, and I was trying to do this in the context of also demonstrating what a while loop does. Okay, so let me do one more thing here and see if you can predict what's going to happen. All right, so if I say while my num is less than 2,000, and let's not print it while we're in the while loop. Okay, so here's the while loop that I have. While my num is less than 2,000, add 300 to my num, and then we can get rid of the delay now since we're not printing anything in here. And then repeat the while loop. So my num is initially going to be 0. So after the first time through the while loop, it'll become 300, and then it'll become 600, and then it'll become 900. All right. So my question is, what value will my num have when the condition on remaining in the while loop is no longer true? So you exit the while loop, and then that value gets printed to the screen. All right. So maybe pause the video while I think about this. All right. You think you have an answer? Let's see if you're right. exploding. 2100? Is that what you guessed? Alright, so why is it 2100? It says while my num is less than 2000. Alright, well the first time through my num is going to be 0, so it's true. And then 300 gets added to it the second time through. My num is 300, which is less than 2000. Then it's 600, which is less than 2000. Then it's 900, which is less than 2000. Then it's 1200, 1500, 1800. And then when 300 gets added to 1800, it becomes 2100. 2100 is no longer less than 2000, so the while loop is exited, and that's what gets printed to the screen, 2100. All right, so that's all for this video. I will see you guys next time.